The final talk before lunch is Bazel Build Analytics with ThoughtSpot, and we have Shishir and Sahitya.
So, hi, I'm Shishir. This is Sahitya. We work at ThoughtSpot, and we'll talk about using ThoughtSpot for Bazel Build Analytics. So, having talked to some of you in the last couple of days, I've realized that getting actionable insights from our builds is a problem that a lot of us are trying to solve. And I don't have to sell you on the importance of build analytics, but I've prepared a few lines or written a few lines that I'll read anyway. So, in a world where we have where data-driven decision making is paramount, Bazel builds and test processes should certainly benefit from the transformative potential of data analytics. And this will allow us to dive deep into the data and derive insights that help you or help us identify bottlenecks and improve our build and test processes. So today, at our place, we had a large volume of complex build and test data, often fragmented across logs. And we did not want to use ready-made or predefined dashboards that are generic and non-customizable for our use case. So we decided to use our own tool, ThoughtSpot, for dogfooding our build and test data. And we'll share the results, and we'll show you how we did that. So before we move on to the demo, I'll take a look at the key metrics that we're trying to explore. And so primarily, we're looking at cache hit rate, which is the percentage of work avoided and rather pulled from remote cache from previously executed actions. So we reuse those artifacts. So we also look at critical path duration, which is the longest. The critical path is the longest sequence of actions that run in a sequence where the next action depends on the output and artifacts of the previous one. And the duration, critical path duration, is the lower limit on your build duration. And we'll also talk about critical path ratio, which is nothing but critical path divided by the total critical path duration divided by the total duration, which is indicative of the degree of parallelism in your build. We'll also look at total build duration, test duration, cache hits for tests, success, failure, and flaky percentage for tests. So here's Sahitya with demo.
Yeah, thanks, Shishir. Let me quickly share my screen. Yeah, so here we have used an open source repo called Bazel CPP for generating metrics for builds and tests. Sorry.
Yeah, got it.
Yeah, so here let's dive right into the metrics for getting the insights for cache hit rate trends. And here are the KPIs and line charts that we have derived for getting the monthly cache hit rate trend. If we look at this line chart, we can clearly observe that there's been a significant reduction in the cache hit rate since July. What does this mean? This means that there has been an increase in the build duration due to the fewer cache hits. And then if we go to average total actions, we see an upward trend since August. And as we can see here that it has increased by 20% since September. Now let's just run a change analysis to find out the attributes that are contributing to this change. Let's just select a test name. If we can see here that this particular test has not changed, then the increase would have been only 13% instead of 20.2. So this some change in this test has led to a increase in 7%. Similarly, we can just select any other attribute to figure out the factors that are contributing to these changes. Now, let's look at the metrics for critical path duration. In Bazel, aiming for a critical path duration rate close to 1 is a performance optimization strategy to efficiently utilize resources, reduce contention, and enable faster code iterations. If we look at this line chart here, we can observe that critical path duration rate has been the lowest in the month of May, and it has been increasing since then. To achieve this, we have added more resources and allocated pods for efficient builds. Then we have the metrics for getting the total number of builds and the pass-fail count. This bar diagram here shows that in case of automation, there has been a lot of commits that have gone in these months. And from this, we can clearly say that we may need additional resources to manage our workloads efficiently. This helps in identifying or making the smart decisions, resource allocation decisions to manage our costs efficiently. And then we have derived the final one, that is the build duration per each invoked target. This bar chart here shows the targets that are contributing to the slowest builds. So if you want to reduce the build time, then you know like which target should be looked at. And here is the monthly build time duration per each invoked target. You can just filter it out by selecting the invoked target that you want, and you can see the trend over here. Similarly, you can just filter it on the entire data to just get the answers for a specific targets. So yeah, so this data has been updated to get the data only for these targets. Yeah, so similar to build data, we have derived metrics for getting the average test duration and the trends for each test. This chart here shows the tests that are contributing. It basically shows the slowest tests. And here is the monthly test duration trend. And we can just select a specific test and see the trend over time. And then we have the average cache hit rate for each test case. This bar chart here shows the test cases that are having a very fewer cache hits, leading to contributing to the overall build and test times. And then we have derived a metric to get the number of test cases for each component. This helps assess if there are sufficient tests in each component. And finally, we have derived metrics to get the success, flaky, and failed percentage for each test. In the repo that we selected, we didn't find any flaky failed tests, but you might wonder, like, why is the success rate not 100%? And this is because we have found a test case which was failing with timeout every time. And again, like I mentioned before, we can just select the test names that we want to view the data for specific tests, or we can just select any component, and your data will be updated to just view the trends for those tests. And yeah, that is how like ThoughtSpot empowers us with actionable insights for our data analytics in Bazel builds and tests. With this, I'll hand over the stage to Shishir.
Yeah, we'll try to wrap it up quickly. Yeah, because next we have lunch. And I can see I have a minute.
Implementation is next one.
Yeah.
Not there yet. Just this tab.
Okay, I wanted to talk a bit about the implementation, but I'll skip that. But if you want to discuss that, you can talk to us. And if you want to try it out, we can help you set up your own ThoughtSpot free instance that you can use to analyze your build data. And apart from the demo that Saitya shared, you can also do, you can also use, if you have flaky tests or failing tests that have been failing consistently, you can map it against the SHA to find the culprit SHA, or if you want to analyze when did this test turn flaky, you can do all that. All these answers, dashboards, KPI monitors are all customizable, and you can modify them to query your build data, and that's rather easy. So yeah, I'll skip implementation, and if there are questions, you can. Okay, I think we are done. Thank you.